In this video, we'll discuss some problem that is conceptual in the theory of vector. The first question is, a car is running at 40 km per hour towards the east. The driver of the car sees a truck running 40 √3 km per hour towards the north. So we have to find out in which direction really the truck is running, and the second one is what is the actual velocity of the truck. So first of all, draw this statement. So here give me some time. This is a car is moving in the east side at the velocity of 40 km per hour, and the car saw a truck driving 40 √3 km per hour towards the north. So this is not the actual velocity of the truck. The car thinks the truck is moving at the speed of 40 √3 km per hour. So this is the speed of the truck with the reference to the car. So this is not the actual velocity of the truck. This is the reference velocity with respect to car of the truck. So this is two vector. This is one vector, and which is acting on the east side, and this is another vector which is acting on the north side, and they are perpendicular to each other. So we can say that alpha equals to 90 degree. So actually the truck will be moving at the speed of vt at the direction with theta. So we have to find out this vt and this theta, as vt is the resultant vector of the vtc and vc. So we can find this vt, like if we write vt square equals to vtc square plus vc square plus 2 vtc into vc cos 90 degree, as alpha equals to 90 degree, and we use the formula of parallelogram. So now put the value. We know the value of vtc equals to 40 √3, the value of vc equals to 40. So let's write this square sign, and we know cos 90 degree will be 0. Now if I calculate the whole formula, then I will get v of t equals to not 40, it will be 80 km per hour. So the actual what is the actual velocity of the truck? The second question of our this problem, the actual velocity of the truck will be 80 km per hour. We solve the second one. Now let's solve the first one. As we have to find this theta, so we can write, as this is the theta angle. If we draw a perpendicular line from there, this is not perpendicular, this is if we draw a perpendicular line from there to there, and that is represent v of tc, then we can say that tan theta equals to v of tc by vc, and we know the v of tc equals to 40 √3 and the vc equals to 40. So we get theta equals to tan theta equals to √3, and we know the value of tan theta, which is equals to √3, equals to when the theta equals to 60 degree. So we can say that the truck is moving 60 degree with respect to east side, side. So we solve our first problem. Now coming to the second problem. The second problem says that the velocity of a sailing boat in favor of the current in the river is 18 km per hour and against the current is, it will not be 18, it is sorry for my mistake, it will be 8 km per hour. It will be 8 km per hour. So from that statement, if we find out the solution, we can say that let us consider, let the velocity of the current is the current velocity equals to u and the boat velocity equals to v. This is u and this is v. So from the statement we can say that when the boat is moving in favor of current, so it will be u plus v, and at that time the velocity is 18 km per hour. And when the boat is moving against of the current, so then the velocity will be, then it will be v minus u is 8 km per hour. If we solve these two equations, this equation 1 and this equation 2, then we'll find the value of u, the value of u equals to 6 km per hour, 6 km per hour, and the value of v will be 12 km per hour. So that means the velocity of the current is 6 km per hour and the velocity of the boat is 12 km per hour. Coming to the next part of our question, let me remove this thing. In our next part, we see that there is a question: in which direction the boat is to be driven in order to reach the other side of the river. So let me draw this concept. Suppose this is the river. This is our river. This is our let me draw this clearly. This is our river and the tide this is the river and the tide is moving at the velocity of the current is moving at the velocity of 6 km per hour. And suppose the boat is moving at that direction with the velocity of 12 km per hour. This is the two side of the river, and we start from this P position, and we have to go the exactly opposite sides of this P, which is Q, which is Q. So if I want to go at that side, then the angle between this current and the resultant vector, that will be our resultant vector, will it act as angle of 90 degree. So the angle of our resultant vector with respect to the 6 km per hour, the current velocity of the river is 90 degree. We know that if I want to find out the angle with respect to this 6 km per hour, we can say that the tan theta equals to, as we have to find out this value which is equals to u, it will go there and v will be go there. We will add some plus and then will be sin alpha by cos alpha. And we know as it going opposite sides of the p side, then the angle between this u and this resultant vector will be 90 degree. So our theta will be 90 degree. theta equals to 90 degree. So we can say, write that tan 90 degree equals to v sine alpha u plus v cos of alpha. From that we can write that u plus v cos alpha equals to 0. So we can write that cos alpha equals to minus of u by v. And we know the value of u equals to 6 and the value of v equals to 12. So the cos alpha, then if we calculate this, then we will get the alpha will be 120 degree. So we found that in which direction, and the alpha is the angle between the two vectors. This is the angle between the two vectors. This is our alpha. This is our alpha, and we found that the alpha will be 120 degree. We solve our first part of this question, which is in which direction the boat is to be driven in order to reach the other side of the river. Now the second part is what will be the velocity, what will be the velocity of the boat. So let me first clear this boat. As we have to find out the velocity of the boat, we will use the law of parallelogram. Suppose this is r. So we can write that r square equals to root over of u square plus v square plus 2uv cos of alpha. If I not r square, r equals to root over u square plus v square plus 2uv cos alpha. If I put all the value like u equals to 6, v equals to 12, then 2 into 6 into 12, and cos alpha equals to cos of alpha equals to 120 degree. So if I calculate all these things, then we will find the value of r will be 10.39 kilometer per hour. So the resultant velocity of the boat will be 10.39 kilometer per hour. So this is the second problem. Now coming to the third problem. The third problem states that a man while running at velocity 4 meter per second comes across rain falling vertically with the velocity of 6 meter per second. And the question is, at what angle he will have to hold an umbrella to protect himself from the rain. So first of all, draw the whole situation. Here, a guy or a man is moving at 4 meter per second, and vertically rain falling with the velocity of 6 meter per second. So vertically rain falling rain is falling at the speed of 6 meter per second. Here the catch point is, we know if we want to perform the parallelogram law, so the 2 point of the vector will be at the same point. But here for the vector rain, the velocity of the vector rain, the point is here, and for the velocity of the point of the guy, the point is here, and these 2 points are not at the same angle. To make this at the same angle, we take the relative velocity of the man, and it will be minus 4 meter per second, and we extend this raining vector which is 6 meter per second, and we have to find out this angle r prime, which is the relative to this actual angle of r. And suppose the man holding an umbrella with respect to him theta, as this is the theta, that will be also theta, and then what will be this? This will be 90 degree minus theta. That will be 90 degree minus theta. So I have to calculate this whole scenario. So first of all, as give me some time to change the color of the pen. As this is 6 meter per second and this is 4 meter per second, then so that will also be 4 meter per second. So if I want to find out the value of 90 degree minus theta, we can write this 10 90 degree minus theta equals to, we know 10 theta means this. If I say that this is AB and this is O, then we can say that 10 theta of the triangle of ABO will be AB by BO, and the value of AB is 4 meter per second and the value of OB is 6 meter per second. And we know the 10 90 degree minus theta means 10 90 degree minus theta. So if I say that 10 90 degree minus theta equals to 4 by 6, which is equals to 0.66, and we know 90 degree then minus 6 minus theta equals to 10 inverse 0.66, and the value of 10 inverse 0.66 is 33.7 degrees. So the theta will be 33.7 plus 90. Oh, not 90, plus 90. I just, it will be 90 degree minus 33.7 degree, which is equals to 56.3 degree. So the man will be holding the umbrella with respect to his velocity is 56.3 degree, and if I want to find out the angle with respect to the rain falling, then the angle will be 33.7 degree. 33.7 degree. So that's all for today's video. In this lecture, we discussed the basic concepts of vector. We discussed the law of parallelogram. We discussed the cross product and vector product. We discussed about components, and now we solve some problem, conceptual problem of vectors. That's all for today's video. We will discuss many concepts of physics in our next lectures.